All right, so we're gonna continue with 3.5, relations and functions. We're gonna do the introduction to functions, and this is tied to 3.6, graphs of functions, the vertical line test for functions, domain and range of relations. So let's go into intro to functions, okay? Let me just give you an example. Let's think of a function as a big calculator. So if I have this, my calculator, something like this, and we have all the numbers here. Let's say we have 1, 2, 3, we have 4, 5, 6. I'm just gonna have to make it bigger. 7, 8, and 9. And we are going to have this button here. So we're gonna have a big calculator with just one button on it, okay? And it's add to button. I can't even like, so just imagine that calculator. And right here, this is the input, where we input a number, okay? And this is the press the button. And when we do that, what happened? Another number appears. Okay? So this is an example of a function. We put a number into a function. Let's say that that's the first step. When we do that, this is known as the input or the domain of the function. When we're putting a number. Now, then the function works its magic. In this case, it's the calculator. And when we press the button in step 2, what happened? Another number comes out in step 3. And this is known as the what? As the output or range of the function. So I'm going to write that down for you guys, what we just did there. So first, we put a number into our function. That's what we did in step 1. We did that. And this is known as or the domain of the function. Let me use my highlight here. Input. So the input or the domain of the function. Now, after that, what happened? Then the function, in this case is the calculator, work its magic when we press the second button in step 2. Right here, when we press this button. And what happened? In step 3, another number comes out. And this is known as the output. Okay? Or range of the function. So input is the domain. Output is the range of the function. And in this case, our calculator has a one-to-one correspondence because that is for every input, we get one output. And that makes sense for our calculator. We expect that when we enter a number and press the button for just one answer to appear. That's what we're expecting. And in math, this is how we define a function. So let me write this down. This part says that our function, in our case, is the calculator, has a one-to-one correspondence, okay? So that means for every one input, we get exactly one output. For every one input, we get exactly one output. And that for just one answer, hold on, that is for every one input, we get exactly one output. And that makes sense for our calculator. We expect that when we enter a number and press the button, we're expecting just one answer to appear. And that is in math, is how we define a function. So here's the fancy definition of a function, okay? It says a relation is called a function when every element of the domain domain is what? The input. Corresponds no, hold on. Exactly. Corresponds to exactly one element of the range. And this is the what? This is the output. So a relation is called a function when every element of the domain, which is the input, corresponds to exactly one element of the range. And let me write down these two examples that I have here. Here's the example 1. So we have X is the input, the domain, and Y is the output, is the range, okay? And we have 0, 1, 4, and 9, okay? And I have the output 1, 2, and 3. Now, zero goes to 0, 1 goes to 1, negative 1 and 1, 4 goes to negative 2 and 2, and 9 goes to negative 3 and 3. All right, now that's one example. Let's go to the other one. Example 2. And we have X is the input, the domain, and Y is the output, the range. All right, so I have negative 3, I have negative 2, I have negative 1, 0, 1, 2, and 3. And over here I have a 0, a 1, a 4, and a 9. So I have the negative 3 goes to 9. The negative 2 goes to 4. The negative 1 goes to 1. The 0 goes to 0. The 1 goes to 1. The 2 positive 2 goes to 4. And goes to the 9. All right. So as we can see, here's the question here. which one represents a function. And how do you know? Okay. So we said that in a function, a relation is called a function when every element of the domain, the input, corresponds to exactly to one element of the range. Okay. Is that happening on in the first example? Is it every element of the domain corresponds to exactly one element of the output? No. 9 goes to -3 and 9 goes to 3. So this is not a function. Let's look at this one. Is every element of the domain the input corresponds to exactly one element of the range? Yes. There's only one line coming out of the input, of every single number in the input, if you want to look at that way. Okay, so example number 2 is the answer. Let me write it down. 2 is, okay. And every element of the domain, the input, corresponds to one element of the range. This is exactly the definition of a function. So there's, like I just said, there's one arrow stemming from each x, only one arrow. Now, let's try to figure out the relationship formula between the domain and the range. Let's try to figure out the relation formula between the domain and the range of both examples. Let's try that. We're going to come up with the equation. We need to make sure that the formula works for every single one. So let's try example number 2. For example, number 2 is going to be my y, I don't know if you guys noticed, 3 times 3. This is like 3 squared is 9. 2 squared is 4. -1 squared is 1. -2 squared is 4. So it seems like the y is equal to what? To x squared. You guys see that? This is the x. And it seems like we need to square this number. And we said this one was the function. Okay, now for example 1, the x, we said here that the y was equal to what? To x squared. And in here, it seems to be the other way around, right? So x is equal to the y squared. So this number 9 is equal to y squared. And we said not a function. Now, oops, sorry. I do have two more relations that I want to show you. Let me just give you one more example. We have so we're going to consider those two. There are two relations. So the first one -3, 3, -2, 2, -1, 1. So the first example, we said that a relation is a function when exactly every element of the domain corresponds to exactly one element of the range, meaning that we're only going to see -3 once in the x-axis. We're not going to see it more than once. So it seems to me like this is a function, right? Y, -3 goes to 3, -2 goes to 2, -1 goes to 1. So exactly every element, the domain is the x, corresponds to exactly one element of the range. Now let's do the next one, the other example. We have so what do we see? I see the 3 here, and I see the 3 here again. So right away, I see the 2, and I see the 2. It can only be 1. So meaning we want it from here, from the x-axis, just one line to the y-axis. From every number. We don't want this. This is not a function. So in this case, this one is not a function. Okay? And we are going to start with the part that we said 3.6. but I'm going to stop here